To deal with rational exponents, we convert the expression into its radical equivalent. So the denominator of your exponent actually becomes the index of the expression of your base, and the numerator, a, becomes your exponent. Now, typically you will apply the radical first, so take the square root, the cube root, the fourth root of whatever your base is first to make the number smaller, and then apply the exponent at the end. So let's try some examples. For the first example, I have 9 to the power of 3 over 2. The 2 is the index, so I'm actually going to take the square root of 9, and then I will raise that number, once I've simplified it, to the power of 3 because that's the numerator. So the square root of 9 is 3, and then I want to do 3 cubed, which means 3 times 3 times 3, and that is 27, and that is it. For the next one, we have 27 to the power of 4 over 3. The 3 in the denominator tells me that I am taking the cube root of 27, and then I will raise that to the power of 4. So the cube root of 27, I'm asking myself what to the power of 3 gives me 27. And that number is 3, and I will then apply that to the power of 4. So I'm multiplying 3 by itself 4 times, and I get 81. And the more examples you do, the more familiar you get with the exponent table. The next one, 16 to the power of 3 over 4. I'm going to take the fourth root of 16 and then raise that number to the power of 3. Now, the reason we do the denominator first and take the radical first is because if I try to do 16 to the power of 3 first, I'm going to get a really large number, and then I have to take the fourth root of it. And first of all, off the top of my head, I don't know what 16 to the power of 3 is, and then trying to take the fourth root of a larger number will be more difficult. So we deal with the index and the denominator first to minimize our number and do things more efficiently in our head. So the fourth root of 16 means I want to think about what to the power of 4 gives me 16, and that number is 2. And then I can do 2 to the power of 3, which is 8. So for all three of these examples, my exponents were positive. If you look below, our exponents are negative. So we're not only dealing with the rational exponent, but we have to deal with the negative first. And to deal with the negative, all we're going to do is take the reciprocal of our base. So I will write 1 over 125. Now, that exponent of 2 over 3 is now positive, which means in the denominator, I'm going to take the cube root of 125 and then square that number. And the cube root of 125 is 5 because 5 cubed is 125. And then I will square that number so that the answer is 1 over 25. Now for the next one, I have a negative exponent again, so I'm going to take the reciprocal. Now I'm going to just write the radical in right away. My denominator is 3, so I'm going to take the cube root of negative 64, and it's okay for me to take an odd root of a negative number. That's possible. If it was an even number that I was trying to take the root of and the base was negative, that would be no good, no solution. So the cube root of negative 64, I'm asking myself what to the power of 3 gives me negative 64, and that number is negative 4. And then I will raise negative 4 to the power of 4. And my answer, 1 over 256. And finally, our last one. I'm going to take the reciprocal because I have a negative exponent, and I'm going to be taking the square root of 49 and then cubing it because the denominator was 2, so that's the index, and the numerator was 3, so that's the overall exponent. So now the square root of 49 is 7, and then 7 cubed is 343. And please make sure whenever you have a negative exponent, you remember that you took a reciprocal. Make sure it's always 1 over that number because some people tend to forget about that.